Hi everyone, welcome to our webinar today, Disaster Recovery Options with AWS. Our presenter today is Robbie Wright, who works with Amazon S3 and Amazon Glacier. We'll begin in a moment, but before we do so, we have a couple of housekeeping reminders. This webinar is being recorded, and over the next couple of days, by end of day next week, Monday, you will have received a follow-up email containing the on-demand links to the presentation deck, as well as the webinar recording. So make sure to look for that in the inbox of the email that you registered for this webinar with. If you're interested in finding this content early, you may do so on YouTube and on SlideShare by searching for the title of this webinar. Throughout the webinar, you'll notice there's a Q&A window where you can submit questions for our presenter and our moderators who are standing by to answer the questions that you may have. Additionally, at the end of the presentation, we will have time for some live Q&A, so make sure to stick around and get your questions answered live. And again, everyone, welcome to our webinar, Disaster Recovery Options with AWS. Robbie, without further ado, I'll turn it over to you.
Well, welcome everyone, and thanks for taking some time today to join us for this webinar on disaster recovery options with AWS. My name is Robbie Wright, and I lead product marketing for Amazon S3 and Amazon Glacier. And we've got quite a bit of content to cover in a short time today, so let's just jump right in. Disaster recovery is a hot topic for us today for a number of reasons. First, many of our customers are telling us that they're starting to feel squeezed by shrinking SLAs that your businesses require for applications that are running in your data centers. And, you know, we really live in a world where nearly every application is considered mission critical by someone in your organization. And often what we're finding is that those SLAs mean that you need to put a DR plan in place for a workload that's never had it before, or you need to change your DR plan for one that does have it today. Second, even if you still have a lot of infrastructure on premises, cloud is the preferred infrastructure choice for disaster recovery, primarily because of the economics and the flexibility and agility that you get from cloud infrastructure. You know, cloud really makes it possible for you to bring DR to more applications, but solutions could look very different for each workload or each application depending on your needs. So let's spend some time walking through how you can define those needs. The first phase of discovery is pretty straightforward. You need to identify the applications that you want to protect and define what protection looks like for those applications. It's helpful to do a business impact analysis to determine what disaster recovery is really worth to your business for that application, and to give you an idea of what cost targets you want to work within. And then based on that, you should set recovery point and recovery time objectives. So let's spend a minute talking about RPO and RTO. A recovery point is the maximum acceptable data loss for an application. So if we plot it in our timeline here, the recovery point is somewhere before our disaster occurs. And our expectation when we set a recovery point objective is that all data up to that point will be recoverable in the event of a disaster. Looking at it another way, if a disaster strikes, we can expect that we'll lose the data between our recovery point and the time of our disaster. You'll find RTO after the disaster on the timeline. So your recovery time objective defines the amount of downtime you're willing to accept for an application. And this tells you how quickly you need to be able to have the application back online in the event of a disaster. It probably goes without saying that as your RTOs and RPOs grow smaller, they can become more complex. The infrastructure that you need and the tools that you need to facilitate a shorter RTO or a shorter RPO, become more costly and and more involved. So it's important to pair your applications with the right type of recovery to fit RTO or RPO, not under-serving those applications or over-serving those applications, because either way leads to either cost implications or falling outside of RTOs and RPOs. Applications can be placed on a spectrum of complexity. Business continuity ensures that the critical business functions continue to operate or recover quickly despite serious disasters. Disaster recovery, or DR, is how you get there. DR enables the recovery or continuation of tech infrastructure and systems following a disaster. So based on your impact analysis, you should be able to define RTO and RPO for an application and fit a DR solution to those objectives. At AWS, we think about 4 general levels of DR support across the spectrum of complexity and time. For our less valued use cases, for RTOs that are in the hours, perhaps, perhaps up to a day, it could be as simple as using your backup and recovery software that you probably have deployed in your on-prem data center today to write a copy of your backup data to an AWS storage gateway or directly into Amazon S3. This is what many of us are used to in enterprise environments for our hundreds or maybe thousands of long-tail applications. We've probably also got use cases that are a little more important, but their business value might not warrant a big infrastructure investment for DR. So let's say we attach an RTO and an RPO of anywhere from 15 to 60 minutes to each of those applications. For most of us operating in our on-prem data centers, these were the applications that were most at risk, primarily because there wasn't really a DR infrastructure that fit them well in the old world. So our DR plan, if you can call it that, was really just kind of to hope and pray that nothing ever went wrong, and then to update our resume whenever something did go wrong, because there was really not much coming back from that. But today there's really a solution. We call this the pilot light scenario, where we have resources ready to go in AWS, but we don't light them up and don't spend lots of money on them until we actually need those infrastructure resources. Now, for business critical services that require RTO and RPO in the minutes, or may even require some like near zero downtime, you should really consider either warm or hot standby, and potentially even consider multi-site deployments for those. These types of solutions typically include advanced orchestration of your DR runbooks and other provisions to ensure continuity. But here's the great news. DR is no longer an all or nothing thing for us. We get to choose what applications need to fail over and what applications don't. We get to choose which applications get which level of DR. So it's sort of the democratization of DR that we're experiencing right now. So, that allows us the freedom to say that some applications are more important than others. So that's the good news story here, is that DR doesn't have to be a one-size-fits-all solution anymore. So let's spend a few minutes unpacking these scenarios. First, AWS has a large ecosystem of partners that complement our services. You can see a high-level list of our storage and ingest-related partners in this slide. We'll focus at different points in our presentation today on a few select partners that provide compelling solutions to replace traditional backup and recovery environments, and provide ease of use, lower costs, and scalability by leveraging S3 standard infrequent access, and Glacier storage classes as cloud storage targets for DR. look at backup and recovery. This is a simple and a low-cost DR approach that backs up your data and your applications from anywhere to the AWS cloud and allows you to use it for recovery from any event. Unlike conventional backup methods, whenever you're backing up to cloud, data is obviously not backed up to tape. Amazon EC2 compute instances are only used in this scenario as needed for testing. With Amazon S3, storage costs are as low as a penny and a half per gig stored for infrequent access. And with backup and recovery, you can assume an RPO and an RTO of, let's say less than 24 hours. So it's good for those less important applications that don't have a high business continuity need. As far as the AWS services that you'd use for this scenario, you'd obviously use Amazon S3, which we talked about a second ago, and you use S3 to store that data with 11 nines of durability of the objects that are stored in S3. And all those nines mean that, really just translate down to your data is several orders of magnitude more durable in the AWS cloud than it is in your on-prem tape infrastructure, even when you account for offsite copies of your tapes. So transferring data to and from S3 is typically done via the network, and it's accessible from any location. If your backup vendor isn't natively integrated with S3, then you can use the AWS Storage Gateway to move data into Amazon S3. And we'll talk more about that in just a minute. Customers often use AWS Snowball initially to load large data sets into hardware arrays that we send you. And those arrays are up to 100 terabytes, and that helps you securely transfer data into S3 without having to saturate your pipe for a long period of time. We also use EC2 to set up the computing instances that will replace the failed infrastructure whenever you need to do a recovery. And then we use Route 53 to switch DNS records to point to new infrastructure or new structure in AWS. As I mentioned before, the AWS Storage Gateway gives you several options to help you get your backup data into the cloud. The File Gateway enables you to store and retrieve objects in Amazon S3 using industry standard file protocols. Files are stored as objects in your S3 bucket, which are then accessed by your backup software through an NFS mount point. Alternatively, the Volume Gateway just presents you a simple iSCSI target to provide a block storage interface. And finally, the Tape Gateway presents the storage gateway to your existing backup application as an industry standard iSCSI-based virtual tape library, or VTL. And that consists of a virtual media changer and virtual tape drives. You can continue to use your existing backup applications and workflows while writing to a nearly limitless collection of virtual tapes. And each virtual tape is stored in Amazon S3. And when you no longer require immediate access or frequent access to data contained on that virtual tape, you can have your backup application archive it from the virtual tape library into Amazon Glacier to reduce storage costs even further. AWS customers do some very creative things, and they routinely come up with solutions that we haven't thought of. We have a customer based on the East Coast of the United States that needed to retire some aging network-attached storage infrastructure. And these NAS devices were being used for file services for end users with Windows and Mac clients. One of the requirements was for full SMB support. This means SMB v3 with Active Directory, SMB signing, header and payload, compression and encryption, and all the goodness of a Microsoft implementation. And there was also a requirement for high availability and failover in this case. To achieve those two requirements, the customer deployed two storage gateways in volume mode. Each one of those was connected to a Windows server via iSCSI. To achieve high availability, they used Microsoft Distributed File Services to present a single share to end users, and the data is stored on both Windows servers. Any component for a Windows server can fail, and the recovery is measured in milliseconds. This provides highly available local file services with two durable copies of the data stored in S3 by the storage gateway service. The cost of those two copies of data in S3, 4.2 cents per gig, is significantly less than storing redundant copies of that data on premises. For the DR site, Microsoft DFS replication is used to replicate the data to a Windows server running in EC2 in the AWS US West 1 region. And this provides a DR copy that's geographically isolated from the primary data set. And the DR copy can be used for file services in the event of a disaster when both on-premises servers aren't available. And for added data protection, snapshots are taken of those volumes in US East 1. Now let's look at a more traditional DR scenario. Let's look at the pilot light scenario. Pilot light DR architecture is great for meeting longer RTO and RPO requirements. It's suitable for business critical services that can sustain from 15 to 60 minutes-ish of downtime, and provides a mid-range cost option for DR. This solution might include third-party tools like Cloud Endure, Racemi, and others. In a pilot light scenario, we have resources that are built around a replicated data set. This basically leaves these resources staged in a stop state to respond to a disaster scenario. Then when events dictate, we start up this pool of resources, cut over the system to AWS in production, and use auto-scaling to match the required production capacity. So in this case, we see a representation of our corporate network. And then the same resources that are pre-configured in AWS that we're running on-prem, but they're in a stop state here. The only thing we've got that's up and running is our data volume for our database, and we're just streaming data into it continuously. So then when an event occurs, we can just cut over our DNS record, take those instances, they start up in a few minutes depending on the load that you have on those resources, and you're up and running in AWS. This is a great solution for small-scale workloads. So the next example is what we call a warm site or warm failover. A warm site is suitable for solutions that require an RTO and an RPO in minutes. These are typically core business critical functions. They are a slightly higher cost DR option, and a scaled down version of a fully functional environment, in this case, is always running in the cloud for warm standby. The warm standby DR approach requires replication of data and services in the AWS cloud so that a full failover to the cloud can instantly occur in the event of a disaster. The AWS services that we'll typically see in a warm standby scenario are EC2 to run the application and web servers. Those are not running after the initial setup. Then we'll use RDS instances for data replication or mirroring. These are always on. We'll use Route 53 to easily switch those DNS records to point to the new infrastructure within AWS. And then we'll use elastic load balancers to transfer traffic across multiple regions automatically for added redundancy. So as you'll see, this is a similar topology to the pilot light scenario we talked about a minute ago. But now we've got those resources that are available. They're there, but they're smaller. Maybe we don't have as many of them that are running in this scenario. So we just have the bare bones of what we need to be able to come back online. And so with that, when we have a failover, those resources are there, and we can use something like autoscaling to add more to the fleet as we start to take those loads off of the primary network. And of course, the other classic example is a hot site. The hot standby DR approach ensures that a fully replicated and ready infrastructure is on standby and ready to take a full production load in the event of a disaster. Full failover in this scenario is instantaneous and automatic, preventing all the impact on operations during and following a disaster. And if you have a multi-site solution, which it would be recommended in this scenario, that would run on AWS as well as on your existing on-premises infrastructure in an active configuration. During a disaster situation, an organization can simply send all traffic to AWS servers, which can scale and handle their full production load. And what we expect in this scenario is an RPO of less than 35 minutes and RTOs, recovery time objectives, in the 0 to 15 minute range. This is obviously the most expensive example of what you could design for disaster recovery outside of a cloud environment. This is a complete one-for-one matchup of everything you have. So I want to, in real time, be able to take my resources and fail over to a complete clone. Again, really, really expensive because everything's there. I'm running 2 of everything, and in a physical world, there are huge cost concerns there because you now have to pay for a second facility, separate data lines from a telco provider, and tons of other things, and the costs mount up really fast. So in this case, for failover, all we have to do is switch our DNS record, and we're off to the races in AWS. So as you can see, you have a ton of flexibility when you're deploying a DR scenario in an AWS cloud infrastructure. We've seen organizations of many different types, spanning from the smallest organizations to the largest organizations that take advantage of multiple different DR architectures to suit different workloads in their environments because they have that flexibility in the AWS cloud. To dive deeper into these solutions, I'd encourage you to go to aws.amazon.com/disaster-recovery. And there you'll find a number of white papers, analyst reports, case studies, and other assets that can help you dive a little deeper into different disaster recovery solutions and how they've worked for different companies. Additionally, we have some architecture resources that live at aws.amazon.com/architecture that provides you a deeper level of detail, including some reference architectures and technical deep dives. And with that, we'll take a few questions from the Q&A window.
Awesome. Thanks, Robbie, for a great presentation. As mentioned at the beginning of the webinar, we will be turning it over to live Q&A here momentarily. Before we do, feel free to answer our polls that you see on your screen, giving us some feedback on today's webinar. Remember that our webinar today was recorded, and you will be receiving the links to both the YouTube recording and the SlideShare slide deck. If you have other feedback for us, make sure to drop us a line at aws-webcasts@amazon.com. Thanks, everyone. Back over to you, Robbie.